In the last lecture, we discussed why part of speech tagging is a challenging task. Part of speech tagging happens to be the first non-trivial task of statistical natural language processing, making use of machine learning techniques. Now, we will discuss today how to calculate accuracy of part of speech tagging, what is the way to report correctness of part of speech tags obtained, how to do error analysis, and then we will move on to discussing the categories that come from part of speech tagging, the linguistic foundation of part of speeches, which are word categories. Okay. So, just a recap of the tags that we had seen for Indian language processing. This is happening in the context of a large machine translation effort throughout the country involving many institutions. We saw that the words have higher level categories in the form of noun, adjective, verb, adverb and so on, and within each large category there are subcategories. So, under noun, for example, we have common noun, proper noun, n-loc, which are special categories. Then verbal noun, which is not there in Hindi, but is found to be important in Dravidian languages. Then in pronoun, again we have many subcategories like personal, reflexive, relative, reciprocal and WH word. Under demonstratives, we have diacritic, relative and WH word, which again are quite common with the pronoun words. So, we remarked that it is often a challenge to correctly distinguish pronoun tags from demonstrative tags. Under verb, we have two large categories, again main and auxiliary. Under main, there could be finite verbs, non-finite verbs, infinitives, gerunds. For Hindi, it is not possible to distinguish them unambiguously from the word itself or from a small window around the word, and therefore, these subcategories are dropped. We work with main verb and auxiliary verb. Then we move on to adjective, and for Indian languages we mentioned adjectives and adverbs cannot be many times distinguished. In English, we have the "ly" suffix, which helps to identify the adjectives, identify the adverbs. Postpositions again are like prepositions of English, and they come after the noun. Conjunctions are coordinators and subordinators. They help join noun phrases, nouns and even complete sentences. Then we come to particles, where we have default particles, classifiers, interjection, intensifier and negation. Classifier does not hold for Hindi. Hindi does not have this particular category, but in Bengali there are classifiers. Then quantifiers are used, which are general quantifiers, cardinals and ordinals. Finally, we have residual tags, which are for foreign words, symbols, punctuation, unknown words and echo words. So, all these form something like a miscellaneous bag. Whatever could not be put in large categories are placed here in this miscellaneous bag. So, this was an account of part of speech tags, which are being used for Indian languages, and this is looked upon as a pan Indian standard. Now, a few remarks are in order for these part of speech tags and their symbols. So, as you can see, these part of speech tags have subcategories, and the subcategories are denoted by the main category underscore the subcategory. Now, the question of is this grouping of tags good enough, is it correct, complete? So, that will eventually emerge when we begin to actually part of speech a lot of data. The ministry funded project from Government of India stipulates that language processing groups create about 25,000 strong corpora tagged with part of speech, and when lexicographers produce tags on the language document, and then machine learning algorithms are used to learn these tags, then we would come to know the efficacy of these tag set. So, this means that we will be able to identify if the lexicographers are comfortable with these tags. Are these tags described well enough, clearly enough, precisely enough, so that the lexicographer has no problem assign a tag to a particular word. And after that, when we submit this tag corpora to a machine learning algorithm, does the algorithm easily learn these tags with high accuracy? This is the ultimate test. Let me write down these two tests for the efficacy of a part of speech tag. So, PoS tag efficacy is a function of one lexicographer slash annotator is and amenability to high accuracy machine learning algorithm. So, we actually have two entities here, human annotator and computer. Okay. So, this will tell us how good our PoS tag set is, and when the PoS tag set is designed properly, it serves both these ends. Like annotators find it easy to annotate data with these tag sets, and high accuracy machine learning algorithms also can be designed. Okay, let us move forward and we discuss now the accuracy measurement in part of speech tagging. First, we show a bar chart which is typically shown for part of speech tag systems. So, you can see here there are two axes. The accuracy is plotted on the y axis and part of speech tags are mentioned on the x axis. So, NN we have seen is the common noun tag. So, for this particular system which is reporting accuracy, the common noun accuracy is close to 100%, and common nouns form the largest chunk of the language data, and therefore, high accuracy here is good news. NST we have seen is a special kind of tag required for Indian languages, where there are words which can act as postpositions and also can act as nouns, things like upar, bahar, niche, aage and so on. There the accuracy is less than 90%. On PRP, which is the pronoun, the accuracy crosses 90%. Demonstrative accuracy is also around that, close to that. Main verb accuracy is high, main verb accuracy is close to common noun accuracy, and this should be. Indian languages typically are strong on morphology, and verb forms are quite unambiguously shown by markings on the verbs themselves. So, it is possible for a morphology analyzer to send the information of verb, and therefore, a part of speech tagger can make use of this information to accurately predict that a word is a verb or not. Verb auxiliary also has similar kind of accuracy, close to the common noun accuracy, maybe about 96% or so, 95%. Adjective accuracy is not so high, that is slightly lower than 90%, and the reason of course is its neighbor, which is RB or adverb. Adverb accuracy you can see is quite low, less than 70%, and the reason for these two categories low accuracy is because they can be quite easily confused in Indian languages. So, Ram अच्छा लड़का है, here अच्छा is adjective, Ram अच्छा गाता है, here अच्छा is adverb, and it is possible that this adverb is far away from the verb, and therefore, from the immediate vicinity of the word it is not easy to disambiguate the category. PSP, which are postpositions, again have low accuracy, which is close to 70%, and the reason should be that it is clashing with the NSTs, the words which can act as locative nouns, temporal locative or spatial locative nouns. So, PSP and NST can be easily confused, and this reduces the accuracy of both. RPs are particles. Particles also have low accuracy, and there are many particles like negative and so on, and this accuracy is low, which needs to be analyzed. Particles need not have low accuracy in general. The conjuncts, which are like and, or, but, etc., corresponding to Hindi, which is or, ya, then kintu, parantu. So, these words are unambiguous and they should be detected with complete accuracy. One needs to investigate why they are not exactly 100%. Quantifier accuracy is again below 90%, which is also a matter to be investigated, because quantifiers also are quite unique and distinct. For example, all, each, every, sara, pratyek, these are quantifiers and they seem to have a low accuracy. This QW was WH quantifier, question quantifiers. Okay. Then QF is again quantifier, has similar accuracy as QW. QC is another kind of quantifier, QO is again another quantifier. Okay, they have various kinds of accuracy. INJ is the interjection, which has very low accuracy, very strangely. Negative again has accuracy which is moderate, close to 90%, okay, and so on. UT is not used in the current tag set. So, this is for some language, and some of these tags are understandable. They are in the tag set which was discussed for Hindi, and some are specific to that language, and the accuracies are in the form of bars. So, from this diagram one can make out which category has what kind of accuracy, and the low accuracy tags are to be investigated further. That is where one has to invest resources, ideas to improve the accuracy, so that the accuracy of the overall system goes up. So, this is an extremely useful graph, an extremely useful way of understanding how the part of speech tagger is working, and it is absolutely indispensable for design of good quality part of speech taggers. One needs to have this kind of per category accuracy report. Proceeding further, how did we come up with that kind of bar chart? Okay, so, here a particular structure called the confusion matrix is of great help. Now, what is done is that the part of speech tags are placed row wise, part of speech tags are also placed column wise, the same part of speech tags. So, if I take a particular part of speech, let us tag a part of speech tag, let us say NN, which is the common noun, we see the row of NN. In the row of NN, I find that for the column under NN, we have about 50,000 entries. NN has been confused with NST 18 times, with pronoun 92 times, then with demonstrative 2 times, main verb 167 times and auxiliary verb 4 times. Okay, one might wonder, how can a noun and pronoun be confused? How can a noun and a main verb be confused amongst all? Okay. We have to remember that in Indian languages there is a phenomenon called conjunct verb formation. Let me write it down. So, we are wondering why NN can be confused with VM. Okay, we wonder at it. Now, how can a common noun be confused with a main verb? The reason is Indian languages have this phenomenon called conjunct verb. Okay. So, this is nothing but a noun or adjective plus a verb in the form of karna, hona and so on. So, for example, ya dena, for example, salah dena, which means to advise. So, in Hindi, for the action of advising, we have a double word group which has salah and dena, 2 parts in it. So, salah is the nominal part in this group. This whole thing is a verb, though the first part is a noun. Okay. And the part of speech tagger should possibly tag the whole thing as a verb, and this kind of problem can give rise to main verb noun confusion. This is the explanation. Okay. So, coming to the matrix once again, the confusion matrix is a very important structure which shows which part of speech tag has been confused how many times with another category. So, noun we have analyzed, that we find that NST has been confused with noun 33 times. This need not be symmetric. NN has been confused with NST 18 times, but NST is confused with noun 33 times. So, this means that for NN we have placed NST wrongly 18 times, and for NST we have placed NN 33 times wrongly. So, this need not be symmetric, of course, as it is clear. Similarly, if we take the dem row, dem is the demonstrative. What is our expectation? From the last few lectures, we understood that dem and pronoun cannot be easily separated from each other, and that is borne out by the data here. We find that the dem has been confused 231 times for pronoun, and 231 times forms a pretty significant percentage of the total number of demonstratives. Okay. So, we have placed PRP for dem 231 times, and out of about 3000 such tags, 200 times this error has occurred, which is about 6% of error, more than 6% of error, I would say. Similarly, the main verb has been confused with noun 225 times. So, this is a matrix. This is also known as the confusion matrix. It is an extremely useful data structure which tells us which category has been confused with which other category how many times. So, going back to the previous slide, while this reports accuracy on each part of speech tag, this is the function of the bar chart. The confusion matrix gives more detail. It shows how many times a tag has been confused with other tags. Now, it is not very difficult to see that the noun accuracy, which was shown on the y axis of the bar chart, can be computed by dividing this number by the sum of the numbers in this row. Okay. And we can see that this is close to 50,000, other numbers are pretty small, and that is why the noun accuracy is close to 100%. Okay. Now, if we take the dem row, then dem has been erroneously marked in here 3 times, then 231 times as PRP, VM 2 times, VOX 1 time, and these kind of errors give rise to the DEM accuracy as 3002 divided by sum of all these numbers. Now, one can understand how these numbers have been obtained and plotted on the bar chart. So, confusion matrix is very useful. We come to other parameters for accuracy checking. How to check the quality of tagging? This is done through 3 parameters called precision, recall and F score. Precision P, recall R, F score, which is a function of the precision and recall. Let us understand how this is computed. Suppose we have this actual set of tags which should have happened. So, how do we visualize this? We visualize this way, that we have the gold standard data. That means, we have language data, the text which has been tagged by their actual tags, and this data is available to us. Okay. So, we have a set of words with their corresponding tags. So, these tags will form the actual set, we call it A. Now, on this textual data we have got some tags by the part of speech tagger. They may or may not be same as the actual tag which is there in the gold standard data. However, we have this set of obtained tags which is called O. So, set of actual tags is A, set of obtained tags is O, and then precision can be measured as A intersection O divided by the number of O. Okay. So, the number of times A and O agree divided by the number of O's. What is the meaning of this? The meaning of this is that precision measures the accuracy as a percentage of what has been obtained. Okay. So, out of the things that have been obtained, okay, cardinality of O, out of the things which have been obtained, what percentage is correct? That is A intersection O. Recall on the other hand is of the actually correct tags, how many have been obtained which are correct. Okay. So, we already know that A intersection O is the agreement set between A and O. This is the number of times the part of speech tagger has been correct. This is the proportion of how many things are correct, how many correct tags have been obtained from the actual correct set of tags. This is recall. So, precision measures how many are correct from whatever has been obtained, recall measures of the correct ones how many have been obtained. Okay. And these two things can be combined to compute what is called the F score. F score is 2 into precision into recall divided by precision plus recall. So, this is nothing but the harmonic mean. Now, the question that may arise is why F score is defined as a harmonic mean. So, this requires a bit of writing. So, we know that harmonic mean is less than or equal to geometric mean is less than or equal to arithmetic mean. Okay. So, this is harmonic mean, this is geometric mean, and this is arithmetic mean, right. And this relationship holds. Harmonic mean is the smallest of the 3 quantities, arithmetic mean, geometric mean, harmonic mean. So, it is clear that if we maximize the harmonic mean, automatically the geometric mean and arithmetic mean also will go up. Okay, ensuring increase in harmonic mean ensures increase in geometric mean and arithmetic mean also automatically. So, if we look at the slide again, when we improve the F score, we improve the arithmetic mean of both precision and recall, the average of precision and recall. We also improve the geometric mean of precision and recall. So, this is a good idea. Now, let me just write down the intuitive meaning of precision and recall. Precision P, these measures out of those obtained what proportion is correct. Out of those obtained, what proportion is correct. This is precision. And recall are measures out of those correct, how many are actually got. Okay. So, this is the measure. Look at the slide again. This intersection area is the agreement between A and O. So, this intersection divided by this whole circle gives out of those obtained what proportion is correct, and this intersection area divided by this green circle measures what proportion of correct things have been obtained. Okay. So, I spent some time on precision and recall and F score, because this is a very frequently used measure everywhere. Now, we note an interesting thing, and we find that the precision, recall and F score, they are different under certain condition and they are same in other conditions. So, if every word is given a tag and no word is left out. Okay. If every word is given a tag and no word is left out, then we know that the size of A is equal to size of O. Therefore, precision equal to recall is equal to F score. Why so? If you look at the slide again, the reason is that the numerator A intersection O is same for both precision and recall, only the denominator is different. But if we place a tag for every word, then this cardinality of O and cardinality of A become same. Okay. Only when the part of speech tagger misses out some words, because let us say it is unknown, it is not there in the dictionary, then we may have different values of precision and recall, and there precision, recall and F score may be different from each other. But in general, when we obtain a tag for every word, these quantities are same. We proceed further on the slides. An interesting thing is the relation between precision and recall. Typically, precision is inversely related to recall. Why is it so? Let us see the graph here. Recall is being plotted on the x axis, precision on the y axis. We see that as recall improves, precision tends to come down. Okay. This can be understood by going back to the previous slide, where the precision and recall have been defined in terms of the intersection area. So, what happens is that to increase the precision, we may do the following, one of the two. One is that we can increase the numerator, that means increase the overlap between the actual tag and the obtained tag, okay. Or we may decrease the size of the denominator, the size of O. Now, when we decrease the size of O, the precision can go up, but actually we are obtaining less and less tags. Okay. We are possibly missing out on words, not tagging them, and that has an adverse effect on recall. If we want to improve recall, then we again may increase the numerator and decrease the denominator. Now, decrease the denominator is not really possible, because the actual set of tagged words are already given. We do not have much control on these, but when we increase this value, when we increase this, try to increase this overlap, then we find that we are sacrificing on the precision. Okay. So, we can have more detailed discussion on recall and precision later. So, in general the behavior is this, that recall increase typically entails precision fall. Now, this situation is quite typical, and one can come out of this situation only by injecting knowledge, and this point is a deeper issue which we can understand later. Now, we move on to the tags on words, and we remind ourselves that part of speech tagging is a layer which sits between syntactic processing and morphological processing. This is a very useful diagram, a classical diagram of natural language processing, where we say that the processing of language happens in layers. Now, each of these layers makes use of rules and resources. We move on to understanding words and their categories, because we have been discussing part of speech tags so long, but what is the linguistic foundation for these part of speech tags? Do they really exist? Does the language entail the existence of these tags? So, we discuss words and their categories, and the first discussion point is the categories themselves. We have this classical conflict in part of speech tagging between lexical categories and functional categories. Lexical category means the most frequent or most accepted category of a word which is recorded in the dictionaries. So, for example, if we have the word quick, for example, quick we know is an adjective, and typically people's perception about quick is an adjective. It qualifies a noun many times, for example, a quick dog, a quick finish, and so on. But quick can also have adverbial category sometimes, not very frequently, many times or quite rarely it can act as adverb. For example, in a colloquial setting you may say come here quick. So, come here quick, this quick is a qualifier for the action coming. So, there it has adverbial function. So, quick has lexical category as adjective. This is what will be recorded in the dictionary. However, in the sentence come here quick, quick has a functional role which is adverb. So, this is the functional categorization of quick. So, this is an important issue we have to understand. In the sentence what is the tag of the word, and in the dictionary what is the tag of the word. So, now we have this part of speech tags, part of speech categories which are nouns, verbs. These are very large categories. Now, there are constraints for these classes. How do we know that a word is a noun? What kind of tests exist for this? So, here there are some simple observations. Nouns can be preceded by definite or indefinite articles, but not verbs. Okay. So, for example, verbs cannot be preceded by an article typically, unless in poetry, let us say. So, a or the cat is fine, but an applauded is a verb in past tense form, and before that would be ungrammatical. Additionally, nouns combine with other words to form phrases, and they can be complements of verbs, and verbs cannot do so. So, what we are discussing is what kind of constraints exist on the behaviors of nouns and verbs, so that they can be distinguished. Now, steal is a verb, steal a car. Now, a car is the object of steal. We also call it the complement of the verb. Now, a verb cannot be the complement of a verb without some changes in the morphology of the verb itself. So, In general, let us keep things simple and say that nouns typically form complements of other words. So, steal a car, but steal and applauded is wrong. Okay. Now, at this point it is useful to distinguish between subjects and complements. In a sentence, there are subjects and complements of a verb. A verb can be looked upon as having subject role and complement role, which have to be filled with nouns. So, these are also known as arguments. Typically, verbs are not arguments of verbs. It is nouns which form the arguments. Here in this sentence, the boy found a watch. A watch, watch is a noun preceded by an article. So, this is a noun phrase. The boy, boy is the noun preceded by a determiner. The boy is a noun phrase. So, found has this subject slot which needs to be filled. The boy fills it. Found has a complement slot which needs to be filled. A watch fills it. Now, what did we learn then? Nouns can combine with determiners, articles, etc., to form a phrase. Nouns can be the arguments of verbs, and these distinguish nouns from the category called verbs. Nouns and verbs both are large categories. Verbs typically do not be arguments of other verbs. Nouns are the arguments, and nouns are typically preceded by determiners, articles to form phrases. The next category is the set of modifiers. Under that, we have adjectives which qualify nouns. A happy man is an adjective. Happy is the adjective. This is the example. Adverbs, they qualify verbs and adjectives. So, he carelessly dropped the plate. Carelessly is the adverb. Very blue sky. Very is an adverb because it is qualifying blue. Very is also called an intensifier. In English, adverbs can be formed from adjectives by adding ly. An exception to this rule is very, well, yesterday. Yesterday is a temporal adverb of time. Yesterday he came. Well is an adverb of manner. He plays well. And very is an intensifier adverb which can go before an adjective. Then there are relators which join entities in a sentence. So, we have prepositions like under, before, of, about. Okay. So, dust under the carpet, horse before the cart, capital of India, a man about town, a story about Krishna. So, these are prepositions. They do not undergo transformations in English. They do not take what is called inflections. Now, we discuss the criteria for fixing the categories or classes. First important clue which comes for fixing the category is semantic. Then morphological category which relies on the word form, and syntactic which relies on the behavior in phrases or structural behavior. So, this is an important point. In all natural language processing, whenever we carry out a test for some phenomenon or some behavior, the test can be either semantic, which requires deep meaning, or syntactic, which is a structural consideration, or morphological, which is based on the property of the word. Okay. So, this is almost like a running theme across natural language processing. Whenever we design algorithms for natural language processing, we test something, any algorithm for natural language processing which tests something is either semantic in nature or syntactic or morphological, okay, depending on whether it is relying on meaning or on the structure or on the property of the word. So, it is important to understand that semantic test is extremely reliable. This is extremely robust. Once you get at the meaning, there is no doubt left. We have the decision very clearly fixed, but semantic test is also very hard to implement computationally. It is difficult to design semantic tests. Syntactic tests are easier, they rely on the structure, the way the words relate to each other to form larger phrases. So, this requires parsing, and this is less complex than a semantic test. Lower than the syntactic test is the morphological test, which relies on the word, its form and its properties, and this is the simplest. So, algorithms typically attempt to remain at the level of morphological processing or word level processing, because the moment it tries to ascend to the level of syntax or semantics, then there are deep waters, there are complex things to be handled. So, we remark here semantic relies on meaning, morphological relies on word form, syntactic relies on behavior in phrases. For example, let us take the word happiness and we ask what is the category of happiness. Happiness we say is noun because it can be preceded by an article. So, this is a syntactic observation, syntactic test. So, a noun when it participates in a noun phrase, it can be typically preceded by an article. Happiness is not an adjective because it does not take any comparative and superlative forms. So, for example, we cannot say happiness are or happinessest. Okay. Like for quick, we can say quicker and quickest, but not so for happiness. There is no comparative and superlative form for happiness, nor can we make such forms by introducing more and most before them, more happiness, most happiness. Okay. That will make it a noun phrase, it is not a degree in the sense of an adjective. So, this shows why this is not an adjective, this is from purely morphological consideration, and the fact it is a noun is given by the fact that it is preceded by an article, it can be preceded by an article. Why is happiness not a verb? Okay. So, this we leave as an exercise for the participant or the student. Please think about why happiness cannot be a verb. So, see if you can make use of simple morphological test, or we have to go to the level of syntax and semantics to decide why happiness is not a verb. One simple thing I can say is that verbs typically have a different form depending on the tense, past, present and future. Here happiness will not change its form depending on whether it happened in the past or will happen in the future or is happening in the present, okay, which is a morphological consideration. Then there are these functional categories. Here is a long sentence which is full of functional category words. Bill thinks that Tom and Dick have been visiting Harriet to ask for help with one of the assignments which have to be finished for the next morphology class. This is a sentence from one of the celebrated linguistic textbooks, and this is a long sentence which has been obtained by gluing together phrases and even sentence parts, and this gluing has been achieved through the functional categories. The functional categories are shown here with underline, that, and, to, for, with, of, the, which, to, have, be, for, the. These are underlined words and they are functional category words. They fulfill particular functions in the sentence. So, that is a subordinating conjunction. When you have that, this that can be either a relative pronoun, the boy that lives in Delhi, here it is a relative pronoun, or that introduces a new sentence. I said that I will go is a new sentence. This is the subordinate clause, and that introduces that clause. Which is a relative pronoun, the city which was devastated in the war, here which is a relative pronoun. So, we have different categories of words, function words and content words. This is important for both language acquisition and language disorder. Typically, we find that when the brain is damaged, so that the language faculty is also badly hampered, we typically find that the patient does not deal effectively with function words, though content words are not affected so easily. Content words carry the load of information. Content words carry the load of information, and they have to be really robust and very error free. The function words play the role of putting together sentence parts and phrases, and even if they are wrong, fairly accurate amount of meaning can still be transferred from the speaker to the listener or from the writer to the reader. So, content words do play the most important role. The relationship between function words and content words is an important one. There are demonstratives, these, that, and articles a and the. So, they precede the nouns, demonstratives precede the noun. These, that denotes a particular noun, a and the, they also denote noun. The makes the noun a definite one in the discourse scenario. Auxiliaries can precede verbs, we are talking about English language. Then we have pronouns, these also are looked upon as function words. Function words and pronouns are function words because they are pretty closed categories. That means, we do not add new pronouns every day. It is only after centuries or 200 years, 300 years that pronouns get added to a language repository. So, in Old English, for example, there was this pronoun called thou, which got deleted later in modern English. So, closedness, okay, the fact that this set forms a closed class is possibly one of the reasons for calling pronouns as functions words. They also function as reference for nouns. Okay. They do not carry the information themselves, but they refer to a noun which carries information. Anyway, so we will discuss these word categories in the next lecture.